everyone, welcome to our YouTube channel DWater. So we are back with the daily questions of the LeetCode. So here we solve the daily questions of the LeetCode. So which is the maximum twin sim of a linked list. Okay. So this is the questions of the 14th of June, which has been asked in the Daily Street. So it is a medium level question, but we will try to make it easy for you. So in this question, it has given we have a linked list of size n, and where n is also even, and the ith node of the linked list is known as twin of the n minus I node if it satisfies some of the conditions. Okay, this is the condition. So in the simple word, we can say that we have to find the twin sum of the linked list. What is the twin sum? So as we know, the given linked list of is always even size. So zeroth node will be the twin sum of the third node. I will explain you. So suppose uh, we have given a linked list 0, 1, 2, 3, and the size of this linked list is n is equals to 4. So we have to find the maximum twin sum. So what is the twin sum? So here you can see this is these two are considered as twin. These two are considered as twin also. So the sum of the first twin is 0 plus 3. It means it will be 3. And the second twin will be 1 plus 2. It means 3. So in that case, these two are same. So we can say the maximum sum will be 3. Suppose we have also given a linked list. Just give me a second. We have given another linked list, which is in this example. So 5, 4, 2, 1. 5, 4, 2, and 1. So in that case, 5 plus 1 will be the twin. So the sum will be 6, and the 4 plus 2 will also be the twins, which is also equal to 6. So the maximum answer will be 6. Okay, so I hope you got my point. So the main problem is that how to write the code for that. Okay, so as we know, we have given a linked list and the number n, which indicates the size of the linked list. In that case, it is 4. So can we think about that if we store all the elements of this linked list into the vector or into the form of the array. So this is the first case. This is the first thing approach I can understand. I can think. So try to make it easy first. So we have created a vector for that purpose, and we will store all the element into the vector, because the main purpose to store in the vector is that if we store the elements into the vector, then we can avail to perform the operation of the indexing. So suppose we have stored the elements into the vector. So this is the 0th node, this is the first node, this is the second, and this is the third index. Okay, so to find out the twin, if I will I can write this as 0, and this is as n minus I minus 1. So if n is 4, I is 0, so it will be 3. So we can find the twin with the help of indexing. Okay, so try to write the code for that. As we have discussed, first we will create the vector for that. And then we will store all the elements of the linked list into the form of the vector. So we will iterate over the linked list. So while head does not become null, we will store the values of the node into the vector. So vet dot pushback will be head dot val, and head will be head dot next. After this for while loop, we have stored all the elements into the vet. Okay. So now we will iterate. We will first find out the size. The size will be vet dot size, which is the n. And we have to find out the twins. If we will go through this element only, then uh, we have iterate over all the twins. So the number of twins will be for the nth length will be n divided by 2. So we will have to iterate over only n by 2. And here we will also make a answer element which we have to return. So the answer is the maximum answer. Okay. So answer will be maximum of answer, and back of I plus back of, we have discussed, n minus I minus 1. Okay. I minus 1. After this for loop, we can directly return answer. So first run this code and compile this. If it is, so it is working fine. Let's submit it. So as you can see, this is working completely fine. So the time complexity of this, actually we are iterating over all the nth node. So the time complexity will be O of n, and here we are using another vector which store all the elements. So the time complexity and the space complexity will be O of n if we do not include any pointers, space, etc. So I hope you like this video. Thank you.